Okay, first geometry unit of the second semester is all about triangles. And like most units in geometry, we're going to start with a lot of vocab. And the vocab is so important so you know what I'm talking about and you know what you're talking about. Triangles are also so hugely important because every other polynomial shape, quadrilateral, pentagon, hexagon, you can find triangles inside those shapes. This is a huge unit for proofs. Proofs are going to be on our own. Getting triangles congruent, lots of different ways to do that. Once we get triangles congruent, we get all sorts of different properties that you know and love about the shapes that you've been growing up with. Like, why are the opposite sides of a parallelogram congruent? It has everything to do with parallel lines and triangles. Why do all the angles of a quadrilateral add up to 360? Has everything to do with the fact that all the angles in a triangle add up to 180. So everything you know and love about geometry is just about related to triangles, including things inside circles that you're not even thinking of. So first thing, we can classify triangles by their sides. You can have a scalene triangle, an isosceles triangle, and an equilateral triangle. This is an important distinction. Different geometry books do different things. Our book is going to say at least two sides. Is this isosceles? Yes. Is this equilateral? No. But this is isosceles and it's equilateral because it's at least two. Scalene means no congruent sides. Another way of classifying triangles is by their angles. So turns out, sorry, my pen hit the keyboard there. Turns out that all angles in a triangle, add up to 180. So you have four different possibilities that all the angles are acute, as in the first triangle on the left, that they are all, if you look here, they're all less than 90 degrees. Here you can have one 90-degree angle. The other two would have to be less than 90. Here you can have one angle that's bigger than 90, so it's obtuse. The other two have to be less than 90. And then lastly, you can have all three be equal. And if all three are equal, then they're all 60 degrees, and we'll be able to show that later today. You probably know that. You can have different combinations. So you can have triangles that are acute and scalene. You can have triangles that are isosceles and right. You can have triangles that are scalene and obtuse. So we can classify triangles with angles and sides, so be ready for that. Other vocab when dealing with triangles that we need to know. Notice the triangle here. The triangle has three what we like to call interior angles. If you create lines that are extended that contain the sides of a triangle, you can see that all of three of those lines have angles that are interior to all three. Exterior angles are made up by a side of a polygon and one side as a line extended. So this is an exterior angle right here. This is a different exterior angle right here. This is a different exterior angle right here. If you choose this side here to be the side of the triangle and this side to extend, notice it's the same angle if you extend this side and choose the other because these are vertical angles. But often when we talk about triangles, I want you to think about three exterior angles. Even though there would be six, right? There would be this one here, or there'd be this one here. But I want you to think about three because it kind of correlates with the three interior angles. Okay, so take a look at this theorem that you actually proved on your last test. So I would love for you to find your last geometry test and look through the proof of why the three angles of a triangle equal 180. It is built using the parallel postulate. without knowing that one line is parallel to AC through B, you couldn't prove this to be true. It is a theorem, but it rests solely on the parallel postulate. It was Archimedes who thought that he proved the parallel postulate, but he made this assumption about triangles. And so from a standpoint of logical systems, assuming there's one parallel line through a point not on a line parallel to the given line, that is logically equivalent to assuming all the angles of a triangle equal 180. So pick your postulate. Do you want the triangle sum to be a postulate? If so, you can prove there's one parallel line. If you want the parallel line to be your postulate, you can prove this. But you cannot have a system where both of those statements are theorems and proved from other postulates. That was a question that plagued mathematicians for almost 5,000 years. I think it was more 4,000, but still, impressive nonetheless. Last semester I got nervous that we weren't actually watching the videos. So I'm going to start hiding little nuggets in these videos to make sure you're watching. So if you're an Algebra 2 student, you've already heard this if you watched your other video. If you haven't, this is in your other video. See if you can find it. I want you to take your left shoe off before class begins. So if you are coming from fencing and it's 10:30, Parker and Eli and Chai, Carter, you're going to be in study hall. Want you to do this before class starts, and you need to do it discreetly. You need to take your left shoe off and put it in your backpack, hide it behind your back and your jacket, just so I can see that you were watching the video. The other thing is I want to see your notes. If I don't see good notes and I don't see your shoe off, I know you didn't watch the video. And then the highest grade you can get in the classwork is a 4 out of 5, because you got to watch these videos to get the most out of them. All right, moving on. Pretty important theorem, but easy to prove, and I'll leave the proof to you, is called the exterior angle theorem. I use this a lot. I call it the EAT theorem, exterior angle theorem. What do you know about angle 1 and angle 2? What do you know about angle 2, 3, and 4? Think about that, because you're going to have to prove this tomorrow. What kind of angles are 1 and 2, and what do you know about them if they're those kinds of angles? What kind of angles are 2, 3, and 4, and what do you know about them? So what can you say about 1, 3, and 4? Well, the exterior angle theorem says that the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. Some words here. The measure of an exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. So here's an interior angle, but it's adjacent to the exterior angle. That'll be a fun proof for you to do. I want to see it by the end of class tomorrow. Another important theorem, and it's interesting, we have a name for things that are so easily proven from other theorems that they're called corollaries. So a corollary to the triangle sum theorem is that any two angles in the two acute angles of a right triangle are complementary. We've actually talked about this in physics class, how we know in a right triangle that these two add up to 90. So it's just so easy to prove from the triangle sum theorem. If you know you have a right triangle. So given you have a right triangle, the two acute angles have to be complementary. That's a quick video for you geometry students. So in your notes, I should be able to see a picture and definition of scalene, a picture and definition of isosceles, a picture and definition of equilateral, a picture and definition of acute triangle, of right triangle, of obtuse triangle, and of equiangular triangle. Then I want to see your theorems. There's 3 of them. I want to see a picture of what interior and exterior angles look like. So I should see a pretty good page of notes, at least one full page of all those things. Write those down, show them to me, and if you don't have your shoe off, then I know you didn't watch the whole video. Hope you had a good night, and we'll see you tomorrow. Please be on time. Peace.